we're going to look here at how to solve this with the graphing calculator. So the first thing I want to do is kind of zoom in here so we can see a little bit better. What is this function that we're working with? We need to be able to enter this into the calculator correctly. So let's start there. Because this is a function and we're going to be using it as a function, I'm going to suggest let's go to y equals to type in the equation for this function. And also, since I see that the first term is really like a fraction, I'm going to use the shortcut key alpha y equals and select this first option n/d, that's short for numerator over denominator, to get a template for a fraction form. Be careful that you're using the negative sign when you see negatives. Notice that's down here at the bottom. That is different from the subtraction sign that you would use in other types of problems. And I type in 32x. Don't forget that's the variable key. That's what you want to use. And then squared. And to get out of that numerator, we could just press the right arrow. And it jumps us down into the denominator, 170 squared. And then to get out of the denominator, again, press the right arrow. And the end of that equation is plus x. So for some of these problems, you could solve these other parts of these problems by hand, paper and pencil, maybe using some other formulas. But again, the point of this video is to show you how to do this on the calculator. So the next thing I want to do is I'm going to press second mode just to quit that particular screen. But it's still there. In Y1, I still have my function, and I can refer to it as Y1. So for example, where you see part A, determine the height of the golf ball after it has traveled 100 feet. If I were doing this by hand, I would write h of 100 in function notation. And then that would signal to me to replace or substitute rather 100 in for x into that equation and simplify from there. Since again the calculator is, instead of using h, it's using y sub 1, I'm going to do the same type of thing on the home screen, but I'm going to use y sub 1 of 100 because it has its own function notation. Now the shortcut key to get to the y variables is alpha trace, and I just press enter to select this first one, and then in parentheses I'll type 100, and when I press enter, now here I am getting the fraction form, but what I could do to change that is I could press math and then select number 2. That's going to change my answer to a decimal form. Notice it brought up the previous answer. I did not have to retype that fraction answer that was here. I just immediately went to math and I selected number 2, and now it's changed it to a decimal form. The reason the calculator gave that to me in a fraction form is because I put the equation in a fraction form in y equals. So as a heads up, just know that that's going to happen. Another option is I could have written this out with just the division symbol. For instance, I could have placed parentheses around the numerator. Oops, that's not the whole numerator. And then divide by the denominator like this. So that's the same equation, but I'm not using that fraction template like I did earlier. And then when I come back here to the home screen, I can refer to alpha trace, but this time I'll select number 2. I'll also input 100. And notice that it gives me directly the decimal form. So again, a matter of choice, really. I'm going to skip on down to the graphing part because the graphing calculator is known for its graphs, right? And that's one of its most powerful features. And of my choices, I'm given this little bit of information here that's really telling me the window to use in my graphing calculator. So the first piece, 0, 1000, that's telling me the X min and X max. So to change this accordingly in my graphing calculator, I'm going to go to Window, and where I see X min, I'm going to change that to 0, and for X max, I will change that to 1000. Off to the side, I see this information about the X scale. That's telling me how far apart each tick mark is placed. So we're counting by 100s on the X scale. Now in the next bracket, these are the Y values, Y min and Y max. They go from 0 to 240. And the Y scale is 20. So we're counting by 20s. There's really no need to change any of this other information, but from this window, now I can press Graph, and I should see a graph that matches one of the 4 graphs that have been provided here. And let's see. Notice how it looks most like graph D. Without changing my window in my graphing calculator, it would have been very difficult to match up the correct graph to the ones provided in these choices for that particular question. Another thing that I can do is I can find Y values when not Y values, X values when I'm given Y values. So for instance, in part F where it says use a graphing utility to determine the distance the ball has traveled when the height of the ball is 90 feet. Let me zoom this out just a little bit here. So when the height is 90 feet, what we're going to do in our calculator is come back here to Y equals. I really don't need this other equation, so I'm going to clear that out. So it was the exact same thing as the first. And I want to type in that Y is 90, a height of 90 feet. Remember the function H in the original notation, that was representing that output or height. So when I press graph, what I see are 2 graphs, and I'm looking for an intersection of these 2 graphs. All right, so all I've done here is I've just taken a screenshot of that same that same graph window, because what I'm trying to point out here, what I'm trying to point out with this is that we want to find these points of intersection. We specifically want to find the X values because we already know that the Y values are 90. Remember that this right here was 90. Y equals 90. And so if we could find those points of intersection, then we would know when, or in other words, that X value, when the height of the ball is 90. So one way I could do that here on my calculator fairly quickly is by going to Second Trace, and then select the 5th option, which is Intersect, which is number 5. You may want to move your cursor a little bit closer to the intersection. That's advisable. And it will ask a series of questions. It's asking first curve. Well, yes, I'm on the first curve, so I press enter. It asks second curve. Yes, I'm on the second curve. I press enter. And for guess, just press enter. And notice it's kind of small right here, but that intersection is it's 101.4. So that's part of that answer that we were looking for in the previous problem. If I need a little bit more accuracy, I can get that right here. And I could do the same thing again, second trace, intersect, but this time I would need to move closer to the other point of intersection before I answer those 3 questions. Yes, yes, yes. with enter, and it gives me 801.7.